Welcome, GeoTrig. This is section 4.6, Congruence in Right Triangles. The essential question is, how can you prove right triangles congruent? Let's begin. So what is a right triangle? Well, it's just a triangle where one of the angles is 90 degrees. So all these three triangles are right triangles. We usually denote that by a little square on one of the corners. That's the 90 degree angle. Key vocabulary from a right triangle. We got two legs, and those are the legs that are connected to the right angle right here. And then we have the hypotenuse. That's going to be the longest side, the side that's opposite of the right angle. So we got a theorem for right triangles, and this is called the Hypotenuse Leg Theorem. So if you have a hypotenuse and a leg of one right triangle are congruent, so if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So basically you got a right angle, and then you got one leg that's congruent, and then the hypotenuse is congruent. We can say that those triangles are congruent. So this is kind of special here, because this is basically side-side angle. And that wasn't one of our combos that we talked about last week that proves proves triangles are congruent. This is just a special case. So SSA doesn't prove right congruent triangles, but in this special case where that angle is 90 degrees, it does prove it. So to use the hypotenuse leg theorem, we need three conditions. They have to be right triangles. They have to have that 90 degrees. They have to have a congruent hypotenuse, and then one of those legs has to be congruent. So only one, not both. So it's like side-side angle. So let's use that. What I can say, since those are congruent, this angle right here for R is going to have to be congruent with angle S right here. So since I have, and here's the thing, I go back to what I know about isosceles triangles. I know that this side XS and XZ are congruent, so therefore the angles S has to be congruent with angle Z. And because angle Z on this shape too. So I know that's congruent with angle R. Well, here I go. I know that I have one angle, 90 degrees, one angle right here, and this side are congruent with angle, side. So now I can say, because I have angle, side, that triangle PQR is congruent to triangle XYZ. Because now I just proved that these two angles have to be congruent because of that isosceles triangle. All right, that was a little messy. Let's try some examples. So pause the video. All right, on the basketball backboard bracket shown below, angle ADC is congruent to angle BDC. So ADC is BDC, cool. And are right angles, and AC is congruent to BC. Are those triangles congruent? So ADC and BDC, are they congruent? And explain it. Well, we can do that. We learned our SSA theorem, right? So we have one right angle here. I know that angle ADC is congruent with angle BDC, and they're both right angles. We'll say they're right angles. So I got right angles right here. Now what I also know is segment DC is congruent with segment DC. So because they both use that side, I'm going to do two tick marks on there just to keep track. And then I also know that they have a congruent side. AC is congruent to BC because that's given. So I have a side, a hypotenuse, one of the legs side, and I have the right angle. So are they congruent? Yes, because they have the given information. A right angle, a leg, and the hypotenuse are all congruent. Let's try another one. Pause the video. All right, two-column proof here. So we are given angle PRS and RPQ are right angles, and that's on the ship figure, and SP is congruent to QR. I need to prove that triangle PRS is congruent with RPQ. So statements, let's go with what we know. And the first thing is, let's go with givens. Angle PRS and I'll say angle RPQ are congruent, or not congruent. They are right angles. So right angles, we'll abbreviate that way. Reason one, given. Also, we'll add something else to that. So we'll add SP is congruent to QR. So those are our two givens. Now step number 2. Well, I need a little bit more information to prove two triangles are congruent when they have right angles. I need another one of these legs has to be congruent. So is it like PQ and SR, or is it this leg that they both share? It's the leg they both share. So what I can say is segment PR is congruent to segment PR. Why? Transitive property. So I'm right transitive property. Okay, so now that I got one leg, and I got hypotenuse, and I got a leg, and I got a right angle, and I got a hypotenuse leg and a right angle, they are congruent. So I can say triangle PRS is congruent with triangle RPQ. Why? Hypotenuse leg theorem. I can say HL theorem. That's all I need to say. And that's it for that example. Last one. Pause the video. Alright, given that BE bisects AD and at C, and we have perpendicular segments AB, BC, perpendicular DE, EC, and AB is congruent to DE. Wow, that's a lot. We're going to prove these triangles are congruent. So the step one, we're going to do all the givens. BE bisects AD at C, and then the rest of that. I'll write it all out. I might as well, because you have to write it as well. So I won't shortcut this. DE is perpendicular to EC, and AB is congruent to DE. So reasons given. Yay. All right, step number 2. Well, I know all that information. Let's use that bisects here. I think that's going to be a key point. So I know that since BE bisects AD at C, so BE bisects AD. Okay, so two of these segments are congruent. Is it this segment and this segment, or this segment and this segment? You got to be careful. You might look at that picture and say, "Oh, they're both bisect," but no, you got to look at the given information. This line is being bisected. AD is being bisected at C. So we don't have a proof that says that BC is congruent to CE yet. But I can say AC and C is congruent with CD. So AC congruent to CD. Why? Because the bisects, when it bisects a point, that cuts it into two congruent segments. Let's see, bisects, let's say divides into two congruent segments. Good. Bisects, it cuts it in half. All right, so what else do I know? Well, those are congruent, and we got a right angles, and then so 90-degree angles, and we got two legs that are congruent, and then two hypotenuses that are congruent. Well, that's all I need. So I can say triangle ABC is congruent to triangle DEC. And step number, why is that? Well, it's the hypotenuse leg theorem. That's it. You're done.